Welcome to the AutoEnginuity ScanTool demonstration. In this demo, I'm going to be showing you generic OBDII. I'm going to first begin by showing you the layout of our software, and then I'll begin connecting to a vehicle. In this case, along the top we have menu bars, the data logging. At this point, the only thing available to us is playback. We cannot record, stop, or pause because we are not connected to a vehicle. This toolbar along the top is a floating toolbar which allows you to move, dock, and resize, and it's representative of the same information in the vehicle, the data logging, I'm sorry. In this case is the vehicle menu items, and you have connect, communications configuration, and saving a session. This data is also reproduced in this toolbar on the side, which again can be moved or docked. There are two more buttons over here that are not in the vehicle drop-down, which is refresh and print data. The print data allows you to save into an XML format the DTC's live data or onboard test results. In the case of refresh, it forces the ScanTool software to refresh the screen in question. So if you run live data or the DTCs, it would start that particular tab session over. Now, along the middle here is the different tabs which represent the different portions of a vehicle. You've got your diagnostics trouble code, you've got live data in a meter, two formats of a graph, and live data grid, O2 sensors, which is essentially a consolidation of several different modes in OBDII, test onboard systems, and onboard test results. The onboard test results is your IM240 and mode 6 data. Along the bottom you'll see actuations, and this is a window shade. Once you click on it, it can pop up and slide back down. You have the option of pinning it, and so you can leave it permanently on the screen, and no matter what tab you're on, it will always be shown. This is a particularly useful feature if you have enhanced support, because in the case of the handhelds, you're put into a particular scenario where you can either read live data or you can do trouble codes, but if you want to do bidirectional controls, you have to do it the way the factory scan tool presents that data to you, and in some cases that can be a little bit clumsy. Now I'm going to dock that back on the bottom and unpin it so that it can hide on its own. And if I ever need it, I just mouse over it and it'll come back up. And I can also open it up wider. Now, each one of the tabs, as you can see here, also has a quick button for it, or a quick keystroke. And as you mouse over, you'll see we have those available to us as well. I'm going to finish with the menus now, and you'll see the options. You can customize the display. That'll bring up the screen so you can change the size and coloring. The settings are pretty basic. We have a DTC library, so you can come in here and change it to a P code or a manufacturer specific code, retrieve it, and we'll show you the description if available. Conversion, pretty straightforward as well. Simply change from the one unit of measure to the next, hit compute. Feature activation. The OBDII generic support obviously is built into all of the ScanTool products. The enhanced car makers, GM, Chrysler, Toyota, Nissan, and these are going to be like the GM family, the Chrysler family, so it's Chrysler, Dodge, Jeep, Plymouth, Toyota, it would be Lexus, Scion. But these are purchased separately. I am going to continue here. We have technical support, help, which will bring up a PDF of the documentation, and about, which shows you the software version, build date, and serial number. You can also quickly connect to our website at this point. I'm now going to continue on and show you a vehicle connection. This will happen pretty fast. I'm going to press the connect button, or I can use the keystroke F2. It looks for the OBDII interface, which it quickly found, and it presents you with the vehicle selection screen. This is where you're going to do your make, model, year, if necessary, engine type, product line, transmission, transfer type. If I go into, say, a GMC, these other fields will become enabled and not disabled, and the reason they're enabled is because they're necessary to complete the selection. In fact, they're so necessary that we show them in red and disable the OK button. And until this selection has been completed correctly, and that doesn't look like it is a complete selection because our tables aren't showing any data. Obviously, if this is incorrect, you will be presented with the wrong table or no information at all. Now, I'm going to use the Get VIN button. We're connected to a Lincoln Navigator. It's a late model, so it does support electronically reporting VINs, and I'm going to let the software decode the make, model, and year for me. And in this case, these fields are not necessary. Now, here is the vehicular support for our software. I'm going to simply select generic OBDII because at this point, that's all we're going to demonstrate. With OK enabled, I can now continue on. I'm going to select OK. Now it's going to complete the electrical connection of the vehicle. It's going to pull the Mode 1 data out for the OBDII PIDs. It will load all of the enhanced PIDs if it had any. It would grab the Mode 6 data. That would come in right there, and once that's completed, you'll begin what we would consider a diagnostic session. And the first part of every diagnostic session is essentially retrieving trouble codes. In the case of OBDII, there is only one controller, and that is the current one we selected in this case, OBDII. If I had selected airbags and I select current, it would pull just from the airbags. What all does is pulls from every single controller on the vehicle, and it would report the trouble codes underneath the name of the controller over here on the left. So let's begin by doing current. And now it'll pull the Mode 3, the Mode 7, and if applicable, the Mode A. Now this is a 2010 model, so Mode A is available on this vehicle. We do have 2 trouble codes stored under the generic system, and as I stated before, if you clicked all, you would get a list of the systems here. So it may say airbag, ABS, GEM, rear entertainment module, and under each module would be a trouble code and its description. The extra information, whether it's a status byte or a freeze frame or enhanced freeze frame, will enumerate underneath each one of the trouble code entries. In generic OBDII, these are the ones we have. You'll see that this is a red check mark, not a blue check mark. We use red to signify that it is a stored code, and blue to signify that it is a pending code. Also, you'll see that the check engine light is illuminated on the vehicle, and the software reflects this right here. If I hit clear, this is kind of like the mirror for retrieving trouble codes. You also have clearing from all controllers, the currently selected controller, and none. Clearing does a little bit more than just removing the stored and pending trouble codes. It also will reset your freeze frame data, the O2 Mode 5 setup, the IM240 and Mode 6 data, and it may reset your fuel trims. We're going to bypass this and select none. Data is represented in 4 different formats. You have the grid, graphs, and meters. And now I can select a sensor by simply going into the list, pulling it down, and you'll see that it changes to represent data we're looking at. Now, each one of the sensors will change. Now, something that's really unique to the AutoEnginuity ScanTool is if you select a sensor and you decide to view it in a different format, whether it be a graph, a meter, or a grid, you do not have to reselect those. Typically in the handhelds, if you were to change the display format, you would also have to start essentially the live data session over, and we can bypass that all. Something that's also very nice about the AutoEnginuity's interface is the ability to remove all sensors with a single click and add them with a single click. It's a huge time saver if you want to just peruse all the data very quickly without having to discriminate one sensor at a time. and you'll see that it's beginning to update and it scrolls down. Let me explain how the data works with ours. You get the sensor name on the left. You will get the ellipses right here, which is just the 3 dots. That means there's more data inside. And essentially, once you click in there, you can change the sampling rate. It defaults to 100. 100 milliseconds is the generic OBDII sampling rate. If you speed that up, your truck or car may not have the data throughput to keep up with it. In that case, data may drop or it may not report at all. What we usually use sampling rate for is to slow down inconsequential sensors like coolant temperature and speed it up for ones like engine rate. Not speed it up in the sense that we move this to 0 or 50 milliseconds, but in the effect that we do not sample from some of the other sensors as quickly or as often, allowing more bandwidth to another sensor. The domain and range is the rate at which you want the software to scale its output. In this case, if I wasn't going to go past 4,000 RPMs, I can simply change it from 9,000 to 4,000, and it will dramatically change how this reports in. It may not show it so much here, but if the vehicle's running and 9,000 RPMs was 100%, now 4,000 RPMs is 100%. So subtle variations in idle would start to show up in this particular little range grid. Now, the domain and range is again represented right here, and you have a color-coded version of the value inside of the domain and range. And this doesn't mean that 100% is bad or 100% is red is bad or green is good. What it just shows, it's an indication of where it is inside of the range. Okay, so you're going to have to use your diagnostic skills to determine if that's wrong. This is just a visual marker of its position in the range. One last thing I want to touch on is unit of measure. In this case, I can change it from C to F with a single click. This is another nice feature if you're used to using some of the factory scan tools. Again, you'd have to back up and restart the entire session just to change the unit of measure from kPa to PSI or bar. In this case, I can simply select it and change it as necessary from MPH to kmh. And this is available whether you're doing a graph. And I can come down to the bottom here and configure the sensor or turn the sensor off. Now I want to show you the O2 sensors. What the O2 sensors is a way to view the mode 1 data specifically scaled. This vehicle is obviously not operating, so the O2 sensor output voltage will not oscillate as you typically would expect here. What we've done is taken the mode 5 data and consolidated it into one. So here's your mode 5, here's your mode 1, and here's your mode 1. Now we've got the fuel loops open or closed, and we color code again green, yellow, or red. And so you can quickly determine whether, if it's not in a closed loop, then the output from the sensors isn't going to be operating at its normal capacity. So when the vehicle is running, it would oscillate up and down, and you would be able to tell the health of the O2 sensor, or at least the more or less the health of the fuel system itself. Mode 5, if the vehicle supports it, will report in here, and you can see on the left it says 1, and over here it shows 1. What these do is they show you what the waveforms should typically look like as the manufacturer described them. And the software has a zoom to voltage and zoom to trim. And when you zoom to voltage, it will zoom to the presets of the mode 5. Now this vehicle doesn't have any, so we're going to zoom to the industry's known standard of 0.1 and 0.8, and the graph will overshoot that just a little bit so that you can see the lines. Now you also have the ability to view two sensors at the same time. So if you wanted to look at the trims for one and the voltage for the same sensor, you can see on the left it's in red, the voltage is in red, and it's telling you it's in red. And this one is, we've zoomed in, so the range is farther out than what we have. Now I'm going to show you here on the right that this one is in blue, and you'll see that it's in blue and it displays in blue. Now a nice thing is if you hold your mouse over the displaying plot, you can actually see its value. In this case, 99.06 is the maximum, and the SAE says that if a sensor is not inputting, it can report the maximum. So that's actually a lawful value in this particular case. I'm going to move on to the test on board. These are the more in-depth system level bidirectional controls: power balance, key on engine off, key on engine running, crank learn, yaw reset or calibrations, conditional based service resets, and in the case of generic OBDII, you're going to have EVAP as the only one available and not on this vehicle. Bidirectional controls on a component level are down here on the actuation tab. If this was in an airbag, or, well, in the case of an ABS, you would see hydraulic pump, inlet and outlets, and the commanded is the state at which you want it on, off, and you would simply select that, and it would pump it to the vehicle. The last tab in question is the onboard test results, and this is your IM240 and your Mode 6 consolidated, much like the way we did with the O2 sensors. And you'll see a common theme of color coding through the software. In this case, we've got green for good, yellow for not supported, and in the case that red, that means it would have not completed. Also, the Mode 6 data on the bottom you can see is starting to pump in. We scale and translate as the vehicle manufacturers publish this data. We put it in our ScanTool, so it's an ever growing occupation for us. As this comes in, you can see all of the Mode 6 data for this particular vehicle. It'll take just a few seconds to get it all in. And in this case, we even have one in yellow. Now again, yellow is not an indication that it is a warning. You should, that part is about to fail. What it is we're just showing you that it's at the limit of the range and you should take a chance to look at it. If it's in red, we're saying that it is at the edge of the range. And in this case, if you got a red for not complete, that would obviously be something you'd want to look at, but you would also find the Mode 6 test should be in red down here, and it'll give you a quick flag for which one to start looking at. That is essentially the AutoEnginuity scan tool being displayed in completion. Essentially now what I can do is show you the final stage. I can hit refresh and it will start this entire process over as if you started from the page. I can hit disconnect